day everyone. Today we will talk about how we can define different variables, vectors and matrices. We will also talk about how to access to different elements of these vector and matrices that we are creating, and how we can do some simple operations on MATLAB. And finally, definitely we will do a few examples. So let's get back to our MATLAB and remember the command window. And here we want to start to define some variables. The first one, we will define a single variable. So we will write, for instance, a is equal to number 25. And if you remember, if you put a semicolon at the end, it means that when we press the enter, we are executing the command, but the echo is off. So if you go to the workspace, you see that we have the variable a, and its value is 25. Now, we want to start to define a vector. The first type of vector that we will define a row vector, a vector which has one row and several columns. For instance, b is equal to a vector of 1 by 3, and the elements are -1, 0 and 1. Now, in order to define it, what we do is we write b is equal to, we open in a square bracket and we write the values -1, then we put a comma, 0, then we put a comma, and 1, and we put a square bracket. And when I press enter, you see that b is now a vector which has 3 elements, -1, 0 and 1. And as you see here, we have in the workspace the b. Now, another way of defining a row vector is we can write b, or let's say c is equal to -1 space 0 space 1. So instead of the comma, we can use space, and you will see that b and c are equal to each other. Now let's see how we can define a column vector, because in MATLAB the priority of the operation when we have matrices is on the column vectors. Now I am defining the matrix D, the vector D to be a column vector, and the elements, let's see, are 1.1, 2.2 and 3.3. So I write 1.1 and I put a semicolon. Now semicolon means I will go to the next row, and then I put 2.2 and I put a semicolon, then I put 3.3 and I close the square bracket. Now, if I put a semicolon here, it means that I will turn off the echo. The echo is off. But if I look at the D is now a column vector. Now, another way of defining a column vector is, for instance, I could define, let's say I define dr as a row vector, which is 1.1, 2.2, and 3.3. And it's a row vector. I want to convert it into the column vector. We know that in mathematics, in order to do that, we have to find the transpose of the matrix. So I can say that D column is the transpose of dr. And if I do it, you see that the D column, DC, is a column vector. Now, apart from the common transpose, I can also use something like this. I could write DC is equal to dr prime. Now, later we will learn that what is the difference between the transpose and the prime. Now, we have them. Let's clear the screen. We have A, B, C, and D, which are a normal variable, row vector, and a column vector. Now, let's define a matrix E, which has, let's say, 2 rows and 3 columns. Now, in order to do that, we open the square bracket. First, I will type the first row, like let's say -1, I don't know, 0.2 and 1. Now I want to go to the next row, so I put a semicolon. So semicolon basically tells you that you go to the next row. So I have here 2 -1.7 and 1.3, and I put a square bracket. And here you see that E is a column vector, is a matrix which has 2 rows and 3 columns. So let's type whose and see what are the variables that we have. Here it says that A is a 1 by 1, which is a normal variable. B, C, and D are vectors. Well, we call it a vector because one of the rows or columns is 1. D, C, and D are also row vector and column vectors, and E is a matrix. Now, we have defined our variables. We have a normal variable, we have vector, and we have a matrix. Let's see how we can access to these elements. Now, consider the vector B, and I want to access to each element of B. So what I do, I say that I want to see what is B1, which is -1, what is B2, which is 0, and what is B3, which is 1. And of course we can access to the element and change the value. For instance, I can go and say that B3 is equal to 4.2, and when I press enter, it tells you that okay, B3, the third element, has been updated. One thing that you might have noticed, unlike C or Java, the index of the first element of a vector is not 0 in MATLAB. We start from 1. So this is element 1, this is element 2, and this is element 3. Definitely we can do the same thing. For instance, I can see what is D2, which is 2.2, and I can change my D1 into, let's say, 0. And if I do it, I see that the D values have been updated. Now, let's see how we can access to elements of a matrix. Okay, this is the matrix E that I have, and I want to access to the elements of first row and third column. So I write E of first row and third column. So similarly, I can actually access to an element, and in order to update it, for instance, I can go and see that E22, which was previously -1.7, I want to make it to be -0.25. And when I press enter, you see that here this value has been updated. Now, matrix has row and column. And of course, when we have a row vector and a column vector, we also have row and columns, but one of them is 1. What will happen if in a matrix, instead of indicating row and columns, I write something like E4? The question is, which element does it represent? I press E4 and it shows this element. Let's see what is E5. And E5 tell you that we are here. Now, in order to tell you how it works, I'm defining F to be this: 1, 3, 5 on the first row, 2, 4, 6 on the second row. So this is how MATLAB actually gives the elements numbers. In other words, if we have the matrix of E, then if you want to count how many elements, the 6 elements that we have, MATLAB is counting in this form. It looks at the first column and then goes to the second column, and it continues like that. So it is 1, 2, 3, 4, 5, 6. So that's why that if I write E6, it tells me 1.3, and if I write E3, it will give me 0.2. So this is a very important thing that you have to know, how MATLAB is actually giving the value. If you want to just say that what is the nth element of a matrix, this is how the nth element needs to be counted. Okay, let's clear the screen and do a few more examples. A was number 25 and B was a row vector. We know that we can always multiply an scalar value like A to a vector, and in mathematics how we do it, every element of the vectors that we have will be multiplied by this scalar value. Let's define AB to be A multiplied by B, and you see that A has been multiplied by each of these values. So AB has -25, 0, and 105. Now let's define BD to be a multiplication of B by D. Do you remember what was the size of B and D? B was 1 by 3 and D was 3 by 1. Based on the multiplication rule, the result should be a very simple scalar, which is the multiplication of the first element of B by the first element of D plus the second element of B by second element of D, and so on. Now, what about dB? If I write D multiplied by B, I will start to get a 3 by 3 element, because D is 3 by 1, B is 1 by 3, and the result will be a matrix, as you can see in here. Now, what I can do, I can calculate, let's say, G to be the transpose of B, and I want to see what is the multiplication of D and G, which is D multiplied by G. You see, I will get an error. Why? Because D is 1 by 3, D is 3 by 1, G is 3 by 1, and we know that the column of the first matrix should be equal to the row of the second matrix, and if they are not equal, we cannot do the multiplication, so we will get an error in here. Now, let's look at what we had in B and what we had in D. One of them is 1 by 3, the other one is 3 by 1. Let's see what is B plus D. Let's define the variable h, which is B plus D, and when I press enter, I will get an error. Why? Because we know that if we want to add any two matrices, they should have the same size. So in order to do this addition, I can write h is B plus D prime, which is a transpose of D, which already we had it in G. And if we do it, we will see that this is the result of the addition of elements of B and D prime. Because what is D prime? D prime is 0, 2.2, 3.3. And if I add it by B, which we have it in here, we will get the values of H. Now, let's clear the screen and let's see what was D and what was E. D is 3 by 1 and E is 2 by 3. Now, it means that I can multiply E by D and the result will be E multiplied by D. 2 by 3 multiplied by 3 by 1, it should be a 2 by 1 vector. So it is a column vector that we have. Now, assume I have a matrix K, which is some values like -1, 1, 2, and on the second row I have 0, 2.3, and 4. So as you can see, K is also a 2 by 3 matrix. So whose K and E, and both of them are 2 by 3 matrix. Now, what I want to do is, I know that if I write KE, which is K multiplied by A, I will get an error. But there exists lots of applications, especially in signal processing and image processing, that you define two matrices of the same size, and what you want to do, you don't want to apply the matrix multiplication in the sense that we have heard and learned in linear algebra. We want to have these matrices come on top of each other, and we do element-wise multiplication. In order to do element-wise multiplication, I define it in this form. K is a dot multiply E. Dot means we are doing element-wise multiplication. So if I do it, what will happen? If you look at the K and E, it means the first element of K will be multiplied by the first element of E, -1 multiplied by -1, the result is 1. So we do element-wise multiplication. This is very useful when we are, let's say, do some masking in image processing. Now, assume I want to find the S square of E, ES square. So I call it, let's say, E2, and I write it ES square. And when I press enter, we will get an error because we cannot calculate the S square easily by using this notation. However, if we want to find the S square of each of the elements of E, assume that you have, let's say, an error matrices and you want to find the S square of this error, so you can sum all the elements later in order to calculate the maybe mean S square error. What we need to do is this. I will put a dot here and I calculate it. This time I am calculating the S square of each of the elements of E. So element-wise operation is very, very useful. Let's see, for instance, I have EK to be E divided by K, and what we will get is each elements of E is divided by elements of K. As you can see, one of the elements of K is 0, so I have a division by 0. That's why I have the inf, which means infinity. Now, we have defined some vectors and some matrices, but this is not the only way how we can define the vectors and matrices. We will talk about the predefined functions which can be used in order to generate some matrices in upcoming lectures. But before I finish today's lecture, I want you to notice something. We had the matrix, let's say D, vector D. As you can see, by default, what happens is that we have 3 digits after the decimal point. We can actually show more numbers after the decimal point by using a command called format. And if I write it long, if I write it as format long, what will happen? I write D and I press enter. I start to have more precision after the decimal point. Now, what I need to do, I assume that we want to know how we can use the format in a more appropriate form. We will write help format and we'll press enter. And here it tells you what are the way of using the format. If you want to have, let's say, more digit after the decimal point, less digit after the decimal point, if you want to represent it as a hexadecimal and so on, we can use a different type of formats. For instance, we use the format short, and this is the default way of representation. Now, you can play with format and see the different way that the function format is working. Now, I hope that you enjoyed the today lecture and be seeing you in the next lecture.